Okay, today guys we're going to talk about 2.3 and 2.4, which deals with correlation and statistics. So correlation, as you can see right here on the screen, is R, your lowercase r, which measures the strength of the linear relationship between two variables and takes the values between -1 and +1. So again, it measures the strength. Measures the strength of the linear relationship, okay, between two variables. So the correlation is notated by lowercase r. Now with this, the value always lies between -1 and 1. So if we were to draw a little scale here, so we have a +1 and a -1. So right in the middle, let's put a 0. We'll put -0.5. And we'll put a +0.5. Okay, so describe this, not necessarily describe, but to understand what these values mean. So if you're looking at the correlation and you have the 0, that means there is a weak relationship between the two variables. So a weak relationship between two variables. In other words, the dots are scattered. There's no real form of anything. They're just random everywhere. Okay, so it's weak. If it's 0, it's going to be a weak correlation value. Okay, so it's a linear relationship between two variables is very weak. Now, if you have a 1 or a -1, it's very strong. It's very strong. Well, what's the difference between -1 and 1? Well, with that, the negative and the positive is referring to the direction in which the linear relationship goes. So if you have a -1, then you have a strong negative relationship, okay? So in other words, it's going to be going down, like this one right here that we got. You have a negative setup, right? These dots are forming a negative line. So it's a negative value. So if we had a +1, well, that means it's a strong positive correlation, right? In which case, I don't see anything really so much too positive here. But with this, you'd be looking at a positive correlation going in this direction, right? So we had dots going here. And you had it going like that, right? The correlation is drawing a positive line. There's an imaginary line that you could put in between all those dots to be a positive slope. As to where on the negative, the dots are close together, but they're going in a negative slope fashion, okay? For the -0.5 and the -0.5 and the +0.5, that is labeled as moderate. So it's moderately strong or it's moderately weak. Okay, so moderate. So looking at these, I would say maybe this one, it's positive, but I'd say it's a moderately strong because you have them kind of scattered out. I would say this is moderately strong in the positive direction. And we'll discuss this third one here in a minute. The correlation, though, again, goes from -1 to +1. The negative is referring to the direction of the slope. The positive is referring to the positive direction of the slope for the +1. Again, if the correlation value falls in between 0 and -1, it could possibly be just a moderate value, okay? As well as from 0 to +1. It could be a moderately positive slope, possibly, depending on how close it is. So 0.5 is the actual moderate. We give or take like 0.2 either direction. So you say like, 0.7 or 0.3 going in the positive, or you say -0.3 or -0.7. It's still kind of in a moderately weak or moderately strong, depending upon which way it is, just the 0.3 or the 0.7. Okay? It's kind of how I played it out when describing it and what I should play out. So let's describe these. So with correlation, we want to know how to describe these, in which case I use Duff's. Like the Duff's beer on The Simpsons. Okay? So we have direction. Unusual outliers. Get your form and your strength. If you use that acronym to describe, if you're asked to describe a dot plot and you use that, you can definitely label this no problem. So to determine this, on this first graph here, I'm going to get red, and I'm going to say we could draw an imaginary line like that, right? So the direction, we can already see that it is going negative, right? It's a negative direction. Are there any unusual outliers in this case? Is there any dots way over here? Now again, with outliers, they're very apparent. You can see them. You would see a dot way over here, or you'd see a dot way up here. That would be an outlier. So that would be an outlier. But we don't have any of those in this. We don't have any outliers in this graph. So, no outliers. For the form, we want to know if it's linear or non-linear. So in this case, this looks pretty linear. It's actually forming a nice, closely related linear line. And strength. For our strength, we gotta think about this a little bit. So I say these are pretty close to the line for the most part. You would be accurate in saying moderately strong, or you could say strong. I'm going to say moderately strong just because they're kind of scattered. They're not actually all touching the line. So I'm going to say moderately strong. For a strong correlation with this, let's say you had a positive slope, no outliers, or linear, but then you had some dots like this. This would be strong, okay? since we're saying on this bottom, on this first one here on the left we talked about, is moderately strong, I would say this would be sitting somewhere in your R value. That would be probably around 0.7. Okay, moderately strong. The R value for something like this I just drew over here, I would say this would be, oh, hang on, wait, I messed up. What's wrong with that one I just wrote? It's not 0.7, right? It should be positive 0.7. The correlation should be a negative 0.7 because it is going at a negative slope. So negative 0.7. On this side though, if we have a strong correlation, we're calling this strong, and it's positive, that could be close to 1, right? Could be close to 1. Maybe 0.999 or 0.98. Be pretty close to 1. So if we use Duff's on this one, let's see. Looks like if we were to draw a line going through there. Ooh, that guy got squirrely there at the end. I'll redo that one. Alright, that's not a great line, but it's good enough. So we have direction. Direction, we have positive. Any outliers? Well, these are a little far away down here. It's possible those could be outliers. Maybe like this one. Possible outlier. Maybe this one. I'm going to say, just to be safe, that there are no outliers though, because I still feel those are pretty close to the numbers and as far as how they fall. So if you look up further here, you still got something about the same residual distance from this line as well. So for the correlation on this, I'll say no outliers. I'm sorry, for the outliers, I'll say no outliers. On the form, hope everybody agrees that's pretty linear. The strength though, I'm going to say that that would be moderately strong as well. But now what's different compared to the moderate strong we had over here? Moderately strong over here gave us a negative 0.7 as to where this is going to give us a positive value because this is a positive slope. So the correlation should be a 0, we'll just say 0.7. Since we say moderately strong, we'll say the same numbers. Okay? Now, I don't know if that 0.7 is exactly the correct number. I'm just guessing off numbers just to go in there and show that that's what type of correlation number you would get close to with those type of data points. All right, on this third one here, we have, these are Duff's again. All right, so for direction on this one, is there any real direction that you can determine on this guy? I really can't. There's a lot of scatter. It's kind of just going everywhere. So, no direction. So, none. As far as unusual outliers, yeah, you could possibly have an outlier. You could maybe have an outlier here. That could possibly be an outlier. So I'm going to say one possible outlier. Okay, so for the form, well, since it's not giving us any direction and it's not showing anything, I'm going to say non-linear. And for our strength, I'm going to say this because it's so scattered. This is weak. And if it's weak, that means our correlation value is close to 0, so it's somewhere around 0. So it's very weak. These data points are going everywhere. It's very weak correlation. Okay? So again, remember, it's between correlation between -1 and +1. The negative and the positive are referring to the slope, in which case the direction is going, and closer to 1 in either direction means it's strong correlation. So the closer you get to 0 is the weaker. Alright, so now we're going to talk about what affects correlation and what doesn't affect it. So correlation is not resistant to outliers. Outliers do affect the correlation. So with that, let's look at a little scatter plot here. So let's say you have some data points. And then you got one possible outlier way out there. Well, that possible outlier way out there could possibly strengthen the whole setup there with our actual correlation, because that might actually line up the dots a little bit better and actually make it a stronger correlation to the data points. Okay, so with that type of outlier, so we can say it strengthens. With, let's say, another set of data. Let's say we have an outlier way over here. So now instead of falling, this outlier, instead of falling, within the form of the data that's being dot plotted there, it's pulling away from it. So therefore it's weakening. It's weakening, or weakens, shall we say. It weakens the actual correlation altogether. So instead of, like this one out here, making the correlation closer to a +1, this is getting the correlation closer to 0. Now the only other two things I want to talk about here is if you change the units, the correlation stays the same. So in other words, if you change the unit values, if you have centimeters and you change the inches or vice versa on either one of the data points, the dot plot's still going to stay the same because you're multiplying and you're changing both data values the same amount. And if you were to switch the x and y values, the correlation stays the same as well. So even if you switch the data, if you change your x and your y, in other words, you were to change your x values, let me just different color, without confusing anybody. So let's say you have your x values, your y values. If you were to swap these guys, your correlation would not change either. It would stay the same. Okay? And you can play with that a little bit on the Stapplet.com website and play around with those. And I will see you next time.